one kind of trick, and it was on find the inverses. Okay, 60 was y equals, make sure I write it down correctly, log base 7 of 49 raised to the x power. We'll go into a little more detail on why this works the way it does today. Good morning, Emma. Okay, we can rewrite this as y equals log base 7 of 7 squared to the x. Well, now the log base 7 of 7 to a power will cancel. But first, before we do that, what do you get when you raise a power to another power? You multiply them. So this is log base 7 of 7 to the 2x. And the act of taking the logarithm base 7 of another exponent with 7 as its base, those two things cancel out, and this is just y equals 2x. The assignment was to find its inverse, so that will be y equals 1/2 x after you switch x and y and solve for y. Okay, so that's one of them that I think I got right in class but did not explain very well. The other ones that I didn't like how I explained were things like, let's see, find the inverse of the function. With things like 64. Okay, good morning.
Good morning.
Okay, so number 64 was, I'll do that one over on the other board just to make sure there's room. (64) was y equals natural log of x minus 2. Okay? And the assignment was to find the inverse. So finding the inverse function is always, you start by switching the x and the y. Now, there's two ways to do this. One is to think of this as rearranging logarithms. The other way is to think of this as performing an operation. I'll show you performing the operation first. If we take each of these and we picture them, we say that since this is equal to this, we can make both of these sides into exponents, and we're going to make e be the base of those exponents. This is sort of an observation.
Why can we do this?
Well, if this equals this, then e raised to this power will be the same as e raised to this power. So we can do it easily enough. We can say that about almost anything. We could raise them. We could say 5 to the x would equal 5 times raised to the natural log of y minus 2. Why did we pick e? Why did we pick e for this one? What does natural log mean?
Oh, log base e.
Log base e. Because natural log means log base e of y minus 2, then setting up a situation where e is the base and natural log is in the exponents means they will cancel each other out, and we have e to the x equals y minus 2. E to the natural log cancels each other out. If this had been log, I would have raised it to 10 to the x and 10 to the log. If it had been log base 2, I would have raised it to 2 to the x.
So you cross out e but you don't cross out the x?
Nope, e to the x stays the same. E to the x, nothing cancels out because this is not an exponent. I mean, this is not a logarithm up here, excuse me. It's when e is raised to an exponent and the exponent contains natural log, log base e, that they'll cancel.
Okay.
Now I add 2 to both sides, rearrange the order a little bit, and y is e to the x plus 2. That is the, excuse me, that's the final answer of the inverted function. If this is mind-boggling to you, but you were comfortable with everything else about logarithms, there's another step I can take. I can get to this point, x equals natural log of y minus 2. And remember, every natural logarithm is a question, and the answer is the exponent. So if I have x equals log base e, y minus 2, rearranging this like you did the other day would be e raised to the x equals whatever you're taking the log of. So I can go right from here. The base is here. The exponent is the answer. And what's left is what you're taking the log of. This is no different than if I started with 3 equals log base 5, 125. Remember one of the first things we did? We took this statement, and how do we rearrange this? What's another way to say this? Writing it as an exponent instead. 5 to the third equals 125. Okay? 5 to the third equals 125. Same thing, if I can get to here, I can say e to the x equals y minus 2. There's no difference between this meaning 5 cubed is 125, and this meaning e to the x is y minus 2. They're the same thing. Okay? All right, Maya? Yeah. Not today. This is too hard, and we won't have time to go over it outside of class that much. Okay? You need to get this. All right. Okay. Now, that's the stuff from the homework that I didn't think I did a great job with last time. So I wanted to make sure I got that and that we recorded it so you can go over it. We haven't even gotten to the really interesting stuff yet. That starts right now. New notes, okay? Today's notes are on the real reason logarithms. I don't want to overstate this. Yes, I do want to overstate this. Logarithms change the world.
So you're overstating this?
No, I'm actually not. Actually, this is still understating it. Some people have said logarithms are the most original idea ever come up with in math. Some people have said they helped cause the Renaissance. One thing that is pretty literally true.
They're used every day.
Pardon?
Used all over the place.
Yeah, they are used everywhere in math and science. The main thing for their original use was, how did somebody put it? Somebody said that they doubled the working lifespan of any mathematician or scientist in the 1600s and 1700s.
Oh yeah, because you said people they had like contests to see who could be
Yeah.
the best mathematician, and people hired them. So
Yep.
yeah.
And when they said it doubled the working life, it didn't mean it actually expanded their lifespan.
Oh.
It didn't mean it actually made them live to be 200 instead of 100 or 160 instead of 80. What it meant was they could get twice as much work done in the same amount of time. Because the original use of logarithms you could use them to find cube roots, fifth roots, all sorts of stuff. We'll start talking a little bit about how that is today.
I was talking more about algorithms. But
Algorithms definitely. Logarithms in particular are used everywhere too. Logarithmic scales when you're talking about large amounts of time. Decibels
By the way,
are logarithmic. Yes.
Grace is here.
Okay, well, she's not here, so she's absent until she walks in.
Oh,
Okay, but thanks for telling me. Okay. Now, the real reason logarithms change the world.
Do you know it?
Yes. If I have two exponents, for example, if I have two expressions with exponents in it, if I have 5 to the 5th and 5 to the 8th, without figuring out the actual number, tell me what you can do with this to simplify it into one expression. 5 to the 13th. Okay? Now,